CAT 21 slot 2 question number 13. For real values of x, the range of the function fx is equal to x square plus 2x plus 4 upon 2x square plus 4x plus 9 is. You have four options. Now we'll approach this question by two different methods. One is the classical method, and I don't think the classical method will be very long if you understand the method and if you know the method very well. The second method is slightly faster. So in order to solve this question, because x have real values, I can say x square plus 2x plus 4 upon 2x square plus 4x plus 9. Let us say this is equal to y. So what do you get? You get x square plus 2x plus 4 is equal to y multiplied by 2x square plus 4x plus 9. We can simplify that, and x square is common, 1 minus 2y. Then you have x common, 2 minus 4y plus 4 minus 9y. This is equal to 0. And if x, the values of x are real, it means the discriminant of this quadratic equation, x square into 1 minus 2y plus x into 2 minus 4y plus 4 minus 9y is equal to 0. The discriminant b square minus 4ac must be greater than or equal to 0, because x have real values. So discriminant must be greater than or equal to 0. Now understand one thing. This 2 minus 4y becomes b, 1 minus 2y is a, and 4 minus 9y is c. Quickly performing b square minus 4ac, 2 minus 4y whole square minus 4 multiplied by 1 minus 2y into 4 minus 9y is equal to 0. So you expand this now. 4 plus 16y square minus 4 2s are 8, 2s are 16y minus 4 into 4 minus 9 and minus 8, so minus 17y, and plus 2 into 9, 18y square. This must be equal to 0. You simplify this equation, you get minus 4, this should be greater than equal to 0, not equal to 0 but greater than equal to 0, because the discriminant b square minus 4ac must be greater than equal to 0 if x has to have real values. So what do you get? 4 plus 16y square minus 16y minus 16 minus 4 into minus 17 plus 68y and minus 72y square is greater than equal to 0. What do you get now? You get 4 and minus 16 is minus 12. 16y square minus 72y square is minus 56y square, and minus 16y, so you get plus 52y, must be greater than equal to 0. You can multiply the entire inequation by minus 1, and when you multiply the inequation by minus 1, the sign of this inequality will change. So what do you have? You have 56y square minus 52y plus 12 is less than equal to 0. We have multiplied this whole equation by minus 1. And now what do you get? Divide by 4. You will get 14y square minus 13y plus 3 must be less than equal to 0. And which gives us 14y square minus 7y minus 6y plus 3 is less than equal to 0. What does it mean? 7y into 2y minus 1 minus 3 into 2y minus 1 is less than equal to 0. and so we have 2y minus 1 and 7y minus 3 is less than equal to 0. Now the critical points here are 1 by 2 and 3 by 7. So if you plot the critical points, this is 3 by 7, this is 1 by 2, plus, minus and plus. So for less than equal to 0, you should have the range between 1 by 2 and 3 by 7. So what is that range? That range must be okay. Now one thing that we can easily see is that this fraction will never be exactly equal to 1 by 2. So it will be closed interval 3 by 7 to 1 by 2. So closed interval 3 by 7 comma 1 by 2, which should be your answer. Option D. Now let us look at the same question by another method. So what does the other method say? Our function fx is x square plus 2x plus 4 upon 2x square plus 4x plus 9. So now what do? You say fx is equal to, now you have x square, you have 2x, you can write this as x plus 1 whole square plus 3. And similarly, I can write the denominator as 2 into x plus 1 whole square plus 7 in the denominator. So this function, if you closely observe, will have the minimum value when x plus 1 is 0. So when x plus 1 is 0, the function will be exactly equal to, or when x is equal to minus 1, the function will have the value exactly equal to 3 by 7. So when x plus 1 is equal to 0 or x is equal to minus 1, the fx will have minimum value of 3 by 7. And I would have got the answer on the basis of this alone, because there is one closed interval, and so I will eliminate D and B. So 3 by 7 is one, it's the smallest value. What about the largest value? Can we get the largest value in some way? When do you think will the value be large? The largest value of fx will be when x is very, very large. When x is very, very large, 3 and 7 will become negligible. And hence, this fraction will approach x plus 1 whole square upon 2 into x plus 1 whole square. It will approach 1 by 2, but it will never actually be equal to 1 by 2, because it will approach 1 by 2 when we ignore 3 and 7 respectively. But can we actually ignore it? No. So 3 by 7 is the minimum value exact, and 1 by 2 is the maximum value, and 1 by 2 is, we are approaching 1 by 2 in this particular function. We will never reach the value 1 by 2, which is your answer.